Problem 7 of set 5 gives us a baseball diamond with sides of 90 feet. It has Edgar, who's up to bat, running home run at 18 feet per second. It wants us to express the distance between Edgar and home plate as a function of time t. It's going to be a multi-part function, and then we have to try to sketch the graph of the function. So I went ahead and drew my own baseball diamond here with just labeling each side at 90. And then I used our knowledge of him running 18 feet per second to figure out how long it would take him to run 90 feet. And so you just divide 90 by 18 and you get 5 seconds per side of a baseball diamond. So at first base, he's going to be at t equals 5. Second base, he's going to be at t equals 10, and then 15, and then 20 for when he makes his way back to home. I decided I was going to make a 4-part function for this, one for each leg of the diamond that he was running in, and setting the restrictions to the times that we figured out at each base. So the first one, all you're doing is figuring out the distance he travels from the start to somewhere in between here, which is just a straight line. So you can go ahead and express that as d of t is equal to 18t when t is between 0 and 5. So then we need to figure out where he's at between second and third base. So I just drew some imaginary point here, and then made a triangle with the distance that we have to find, and then the side of the diamond, and then this little section right here. And then if we, I just kind of extracted that triangle from over here, from over there, brought it over here, and then found the distance of each of these sides and used Pythagorean theorem to get the distance. So the bottom is 90, that was given, and then the side, we're gonna do basically 18t, except that in place of t, because we're doing it between t5 and t10, the way I want to think about this is the amount of time that has passed since he hit or touched first base. And since we know he touched first base at t equals 5, we just do t minus 5 to get the difference, multiply that 18, and that'll give us that side of the leg. And then we can go ahead and plug, I distributed the 18 to the t minus 5, you get 18t minus 90. And then that now gives us d of t for between 5 and 10 seconds is the square root of 90 squared plus 18t minus 90 squared. Then we want to do the same thing for finding third base, except the problem is we don't have a triangle for when we're adding up, so we have to find the difference between 90 and then this side. So we do the same thing to find this side, and then do minus that and make that part of a triangle. So here you can see that we did 18t, and instead of using t minus 5, we used t minus 10 to talk about how much time has passed since he last touched second base, which was 10 seconds. Distributed 18 to the t minus 10, got 90 minus 18t, or 18t minus 180. And then because what we want to do is do this entire length of the side 90, and then subtract the little portion of it, which we already know is 18t minus 180. So 90 minus 18t plus 180 is going to yield 270 minus 18t. So that's what that side is. I'd extracted a triangle again, so we know that the length of this is 270 minus 18t. And then the bottom is 90. Use Pythagorean theorem in order to find the distance of that triangle, which is the square root of 90 squared plus 270 minus 18t squared equals d of t between t, or when t is between 10 and 15. And then the last thing we have to do is find where he's at between 15 and 20, which is similar to the first leg of the problem where we had to just find a distance on a line. We're going to do the same thing here, except now the t, instead of just it being from 0, it's going to be t from 15, and again we have to find the difference from where he's traveled and here. So we can express that as 18 feet per second times 20 minus t, because 20 is when he is going to get to home plate, and then t is going to be where he's at now. And then distribute the 18, and you get 360 minus 18t. So what our multi-part function looks like is d of t is equal to 18t when t is between 0 and 5, square root of 90 squared plus 18t minus 90 squared when t is between 5 and 10, square root of 90 squared plus 270 minus 18t squared when t is between 10 and 15, and 360 minus 18t when t is between 15 and 20.